25, and I think that broke a record.
Welcome to you brave souls coming out today to the Bucket Course. My name is Sarah Smith. I work in the Office of Community Partnerships Planning and Research here at the college, and I have the honor of partnering with the CEC committee to bring you the Bucket Courses every week. A couple reminders before we get started. If you could silence your cell phones, that would be wonderful. We do have a T-coil in here, so if you need to turn that on in your cell phone, please do that at this time. But otherwise, we today get the pleasure of learning about the skies and about another planet in our solar system, Venus, from Dr. JR Paulson. Today, we're going to have a little bit longer format. So today we're going to take a little bit of a break in between. It's going to go until 11:30. But of course, if you need to go, you can go. And if you need to get up, we don't need to wait till the break to get up. So a reminder that our freshmen are over here on my left, and then restrooms are behind the screen around the corner. So you can use those at any time. But we'll intentionally take a break. Oh, we actually didn't decide what time that's going to be, but we'll figure that out. I'll raise my hand and I'll decide when that's going to be. So I'll take a little break and then we'll come back. All right. So will you please help me welcome Dr. JR Paulson.
Well, it's a pleasure to be here. Is the sound test okay in the back?
Yep.
Excellent. I like this type rather than a mic that you hold in different places like that. Well, let's start out. How many of you have visually seen Venus? Raise your hand. Hey, look around. That's quite a few people. How many have you that have seen it through a telescope? Raise your hand. A few less. Were you impressed through the telescope? Most people go, not so much. Well, anyways, I think you're going to have fun today. And why did I pick this topic? Because when I was a kid, many years ago, and by 8th grade, I could put everything about Venus that I knew a lot of stuff about other planets in about 4 fingers. It was about the size of the Earth, it's covered with clouds, and it's the inferior planet from the Earth, but there wasn't much, and it was really brilliant in the sky. Okay, so that's all I knew about it then. And until not that long ago, that's all I knew about it also. Even with my big telescope, it's not very impressive. So that's why I picked Venus for a topic. Let's see if this works. This is a picture of a conjugation of Venus and the moon as seen 2 years ago from my roof with a smartphone. So obviously the moon's below and that's Venus up above. Pretty impressive. So really, who couldn't be impressed by that? Venus reflects 80% of the light that falls on it from the sun, and the moon, in contrast, only 8%. So Venus, relatively to its size, is much more brilliant, and we'll find out why that is later. Did you know that you can see Venus in the daytime? Many people know that?
Nope.
Well, Napoleon Bonaparte did. He was pretty knowledgeable about astronomy. And he was giving this lecture in Luxembourg in the daytime from this balcony, and he looked up there and says, and there's Venus. And everybody's going, and my little arrow there, you can't really see it much on the left, but it's a picture of Venus in the daytime. It just looks like a little, if you know exactly where to look. And he said that was a good omen to see Venus in the daytime, and that they were going to win this big battle in Italy, which they ended up doing. So the topics that I want to go over today are mythology, history, calendars, and why calendars are really important, observations, naked eye and telescope, spacecraft and probes, atmosphere composition and the weather, surface in the interior, history and evolution of the planets, and are there any lessons for us, and what's coming down in the future with probes and exploration. And finally, is there or has there ever been life on Venus? Mars gets all the headlines. Yeah, is there life on Mars? What about Venus? Well, partway through this, we'll see what you think about that. If you want a nice little reference book about any of the planets, this is a nice little book by David Sorbel, who also wrote the great books, I think, Longitude and Galileo's Daughter, which I know some of you are familiar with. So, mythology and history. The Chinese were one of the earliest civilizations to describe Venus. But in China, they thought it was two different objects. And it represented the blending of the male and the female genders in a married couple. And Taipo was the husband in the evening star, and Nu Qin was his wife, the morning star. And this is a drawing of her, Nu Qin. Now, the Chinese made some of the earliest contributions to astronomy. We think we're pretty hot in the West, but the Chinese were actually quite a bit ahead of us. They developed a working calendar, kept track of comets, and other astronomical things. I found this photograph very, very interesting. This is a cosmic chart with 9 layers of sky. This looks just like a Western model that we have, because their model was geocentric, meaning Earth-centered, just like in Europe, with a third circle being the orbit of Venus. One of the things that shows that they were the earliest civilization to record things was a supernova of 1054. This was a naked eye object. It occurred in 1054 AD. It was observed by several astronomers in China. And they announced to the emperor, I thought this is neat, that it bode great. Remember Napoleon said this was going to be good for my war? Well, it didn't go so well for this guy, because the emperor had them both beheaded. The supernova is a star that explodes. It's in the sky for a number of weeks usually, and it can even be seen in the daytime. It's just the brightest thing that ever occurs. And they recorded it. Tough to miss it. Also observed by Arabian astronomers, but it was not recorded in the European annals. Well, wait a minute, everybody in the West could see it. What's the story? Well, this is where I took my telescope and trained it for a couple hours through different fillers a couple years ago at the same area in the sky that they saw the supernova. And that's what it looks like through my telescope with a long photograph. It's a star that exploded, and all the elements are spread throughout the universe, which we'll come back to later. Now, the Chinese recorded it on July 4th, which is kind of interesting, on 1054, during the Song Dynasty. I'm going to do another bucket course on the Song Dynasty. But Europeans never recorded it. Why not? Because it was based on Aristotle, and the sky doesn't change. It's perfect. Remember, the universe, the moon, the sun, you can't have new stuff happen in the sky. So if you wrote that down, you're a heretic. Well, and it would not go well. But also, this picture that I took isn't what it's like now. That's what it looked like 6,500 years ago, because it's that many light years away. So that's what it looked like 6,500 years ago. Now, the Chinese were clearly not encumbered by by authority or religious cosmology, and were first to discover and record sunspots. And the book of the I Ching, earlier text, 12th century BC, mentions it, doesn't record anything, but that's the first written record then was 28 BC, where somebody wrote it down and say, hey, I saw these funky things on the sun. Remember, this is without telescopes. But in Europe, as I said, they had a harder time accepting this because everyone, including Catholic Church, said nope. Because Aristotle said, nope, the heavens and the spheres are all perfect. However, after the telescope was developed in the 1600s, the Italian astronomer Galileo clearly saw that the sun had dark spots. Galileo correctly figured out that the sunspots were part of the sun itself, and not just something going in front of it or behind it. And he studied it. And this is an image I took some sunspots 2 years ago. This is a large sunspot group called 3664. It has produced massive ejections from the sun, and that turned into the northern lights that we saw in May 2 years ago. Remember all the aurora borealis? It's from these guys, sunspots, which was seen over much of the entire world. In Babylon, the Mesopotamians called the planet Venus Ishtar, or the love goddess. But even in early Western traditions, they still got this confused. Morning star, evening star, they're two different. And it took a while for them to connect the dots. Some of you have heard of in the Christian names Vesper and Lucifer. Well, two different names for Venus. Lucifer, as you know, really was not on the bad religious list, and he was considered the bringer of light. So in the morning, when the morning star came in, that's Lucifer. And that was, of course, before the fall of Satan. The Greeks also, or not also, called her Aphrodite. Some of you have heard of her before. The goddess of love and beauty. And this is a picture of Aphrodite by William Blake. Now, it's really the Romans that got the name that's stuck that we know. So the Roman goddess of love and beauty, the Romans named Venus, and that's the one that we go by today. Paintings of Venus proliferate Western art. Sorry about that. And this is a famous one that most of you have all seen. It's by Botticelli, and it's called The Birth of Venus. I don't know if that's really how she got born or not. This is a famous painting, Venus Disarming Mars by Van Dyck. I became very interested in the art of Van Gogh for a number of reasons, the least of which is astronomy. And this, I'm sure many of you have seen this painting, right? Have many of you seen it? It's very famous. And it's one of the most notable depictions of the planet itself by Van Gogh. It's called Starry Night. And it was painted by him in 1889 while he was in an insane asylum at St. Remy. Can you identify any astronomical objects in that? Or is it just him with his brush doing an impressionistic or post-impressionistic style, of course, which he did? Any of you want to pick any astronomical objects out in there? Or is this just artistic license? Well,
and the sun.
we can now, with the help of computers, go back and look at the sky when he painted that. In the direction he looked. I looked up his room in St. Remy and see which window he could look out. Was it the south, east, north? And then you can go to the computer that I got here. I can just say, St. Remy, this date, this time, this, and it goes back, and that's where the planets were. And notice what's in the left-hand corner, Venus and the moon. This is another one of his famous paintings, entitled Road with a Cypress and a Star. It was painted in 1890, just before he left the sane asylum. What do you think of the two prominent stellar objects? Obviously, the moon up in the right, but that's Venus again on the left. So he's not making the position of Venus up. He knows where, he's seeing it. And lastly, one of his final works, because he committed suicide 6 weeks after he painted this, is called The White House at Night, painted in June 1890. And that big thing up in the upper right happens to be Venus, because we go back to our computer thing and we find out that 8 o'clock at night, yep, that's where Venus was. If you're into astrology, not astronomy, astrology, and I hope you're not, there are many associations with the planet Venus, and this is just some of them. The trees, the herbs, and... Well, let's go over to Central America and North America and the Aztec and the Mayan civilizations in astronomy. I sometimes still get the Aztecs and the Mayans confused. So the Mayans, remember, are much older, and they trace back to 2,000 years before the Common Era. And their peak period, classic period, was around 250 to 900. And continued to exist in many forms until the Spanish conquest in the 1600s, which we'll mention. Aztec civilization, on the other hand, emerged much later, around the 14th century. The Mayans were renowned for their advanced understanding of astronomy, mathematics, and engineering. They built towering pyramids, elaborated palaces, and observatories aligned with celestial events. But, since this is a talk on Venus, the planet Venus is a symbol of death and resurrection in ancient Mesopotamia. And we'll find out that that goes pretty deep. And in contrast to European mythology, Venus was represented as a male figure, which I find interesting. This is the ruins of an astronomical observatory at Chichen Itza that our family visited. I did not take this picture, but we have one just like it, that we saw several decades ago on a trip to Cancun. But it almost looks like a dome-shaped observatory. But they have no telescopes at that point. Human sacrifices played a central role in the Aztec religious rituals. They believed it was necessary to ensure that the sun would rise each day. And while the Mayans also practiced human sacrifice, it was not as central to their religion as it was to the Aztecs. Heart extraction was viewed as a means of liberating the Ishli and reuniting it with the sun. The victim's transformed heart flies sunward on a trail of blood. And they had this chakmal thing that the priest in the top took this knife and cut this person up in front of everybody and took the beating heart out. So these are not just pictures, but this is actually what happened. Are any of you familiar with the American Indians and sacrifice in Venus? I certainly wasn't. Well, Native American skies, the Pawnee Morning Star ritual involved human sacrifice. So I'm just going to read there on that lined area. Looking in the sky, the practice of sacrifice to the morning star was part of the rites of the Skidi band of the Pawnee, a group that had developed a unique relationship to the stars. All of the native groups, no one had gone to develop such an intricate and direct affinity with the stars. They were really into their relationship with astronomy. But for them, the stars were kindred souls, and they took much of it, the direction of it for their life. And so what happened, the last human sacrifice in North America, they, of course, didn't want to sacrifice one of their young maidens, so they stole an Ogallala Sioux teenager, captured her specifically for this ritual, and sacrificed her to Venus. And that was in the 1800s, I believe. How do we know about the Mayans? archaeologists have found 4 surviving codexes, which I'm going to digress and tell a little bit about those, because it's very interesting. So the Mayans did all this stuff, but how do we know about them? Well, these things called codexes were discovered, and there's about 4 of them. And they date back to 11th or 12th century. And one of them, of course, was found in Mexico, and it was sent back to Dresden. It had information, astronomical tables, religious references, seasons of the earth, illnesses, medicine, all this information, particularly about the planets. Now, these are so rare because what happened in the Spanish Inquisition, when they came, they burned, they destroyed all of the written records and things of the Mayan. So, but they didn't get these 4 codexes. Let's see. I think I did the Dresden Codex. Yeah, so the Dresden Codex is one of the most famous. It was created around Chichen Itza, around 1200s. It was sent as a tribute to Charles V, the Holy Roman Empire, by Cortez. So he said, I'm going to say, these books are kind of cool, and I'm going to send this one. I'm going to send it back to the Holy Roman Emperor as a tribute. He'll be impressed. And it's complex. It's what eventually we used to decipher the hieroglyphics, so we can read the stuff. Well, they did a lot of things, and Holy Roman Empire said, yeah, that's kind of cool, stuck in the library someplace, and they just got stuck there. These are some pictograms that you'll see on them. You're familiar with the drawings, but these are also the numbers. They're numeric system that they use to write down all these numbers, which we'll get to. However, well, let me tell you about the codex again. So it finally gets in the Dresden Library, and it's stuck in there for hundreds and hundreds of years. So in the late 1900s, some historian guy goes in there and says, "Oh, what's this?" And he's the one that figures out that this is the language and to be able to interpret it. Okay, so however, the greatest culmination of all this Mayan observation was the creation of a working calendar. It's a stone carving of a Mayan calendar. Now, what's so big about calendars? Yeah, it tells you when spring break is. Yeah, it reminds you when birthdays are. Yeah, it tells you when one comes and goes. It tells you when your taxes are due, right? I mean, all these important things are calendars. If you screw up on them, it may not go so well, because you don't get your taxes in, right? So they're used for religious, they're used for farming, when to plant, when to harvest, and all these civil events, right? But we'll talk about the week first. Where did the week come from? Chinese 10-day week. Romans originally had an 8-day week. Celts 9-day. Aztecs 5-day week. So the 7-day week that we go by was invented by the ancient Mesopotamians about 4,000 years ago. But we're not sure why they chose 7. Because there's no real astronomical. So that finally reached the city of Alexandria, which was the center of astronomic study. And of course, at that time, most calendars were based on the movements of the 7 visible astronomic objects. Well, there's only 7 of them you could see. Do you know where the names of the week came from? This is a little trivia, but I think it's fascinating and related to our topic. They're all based on mythological characters, either directly or else they're patron astronomical objects. Monday, Tuesday, Wednesday, Odin, Thursday, Thor, Thursday, Friday, day of Frigg, the goddess of love. There's Venus. So So Friday's love day, folks. I thought I'd tell you. Saturday, geez, Saturn, Roman father god. And Sunday, pretty easy to figure out the sun, right? And Alexandria was a Hellenistic or Greek-based city, and so they gave them the Greek name. So that's how some of the Greek names of the week came. But then the Romans gradually adopted the 7-day week after Julius Caesar's calendar reform in 46 BC, and he consulted astronomers from Alexandria, because we're going to talk about his calendar in a couple seconds. But the names of the day were changed to their Roman equivalents. Okay, so yeah, Dies Jovis, Dies Solis. But our language, the English language, German and Dutch, we use these, you can see how it morphed through our languages. So now you can really see in Friggy Day Friday, oh, that was the Rome, the goddess, German dramatic goddess of love. So all through these cultures and time, the gods and planets kind of stayed forever, which I think is kind of neat. But, as many of you know, there was a problem. And Julius Caesar had his calendar, but pretty soon it wasn't coming out too well. You know, events, Easter wasn't happening when Easter was supposed to happen. All these things were getting screwed up, and they go, what's going on? So, the Gregorian calendar was the reform. And so what did they do? They did two things. They said, we're off 10 days. So just scrap 10 days. So tomorrow is not going to be the 12th. It's going to be the 22nd. And of course, everybody gets upset because, well, what happened to all those days that we just lost? Well, too bad. Deal with it. And two, we got this leap year thing kind of screwed up. You know, we have to put this fudge factor in periodically, or we're going to get screwed up again. So we got to tweak that again, and every 4th year we'll add something. But we can't do it on certain centuries. Well, so all this fix was pretty neat. Well, but I find this really fascinating. So Pope Gregory made an edict in 1582. But take a look and find out when the other countries in the world decided to get on the same calendar page. United States, not till 1752. Look at China, 1912. Russia. They didn't get on the calendar. So all these places in the world, I don't know how we got along. You know, when you say, well, I'm going to do this in this date, and everybody in the world does all this different stuff. You send a postcard and put your date on it. It goes to someplace else, and no, they're still back on. Another tree fact I thought you'd be interested in. Okay. Now, what about the Mayan calendar? And you say, why is it related to Venus? They really developed a sophisticated calendar. The Mayan calendar was based on the morning star and the risings of Venus, which occurred every 584 days. Venus was the centerpiece of the Mayan cosmology and mythology. It created a framework of cycles, predicting future morning stars. When's the morning star going to come again? And then when after that? But they could also predict solstices and eclipse dates. Now, the timekeeping of their calendar was a combination of several different calendars. So they didn't have one calendar like we do, you write everything on it. They had a sacred calendar. It was 260 days. But the second calendar was a civil calendar. That's when your taxes are due and all this stuff. So they have two calendars and it's different days. So you go, well, that's kind of screwy. So one's called the Zolkin. And again, it tells you when the religious events and ceremonies are and what's coming up. And the other one is called the Hop. And this is 365 days. Oh, that's interesting. That's the civil calendar. Well, what's remarkable, these calendars work together. So you got these two calendars, and if you click them around like that, they show you more stuff. What stuff do they show you? These wheels work together and they use simultaneously. And then there's the third calendar, that big wheel goes around. It's called the calendar of the round. And that extends out. So you got all these two calendars working together. Now, I certainly don't understand it, but what's interesting is these cycles synchronize every 52 years. And the Venus cycle fits very closely in there. And the Venus round was a sacred day, so that was, of course, in there. And so they use this to track Venus. But on a vaster scale, this long count calendar measures the precession of the equinoxes, and that cycle that they figured out is 25,695 years. So imagine these people figuring a calendar, what the heck is going to happen 2,500 years ago with the instruments and the stuff they had. I mean, to me, that just blows me away. They also anchor it with remarkable alignment. The meeting of the winter solstice in the Milky Way. And I'll show you what that means in a minute. But the winter solstice, of course, is the shortest day of the year. And it's represented as a spot in the sky. And it can vary through the sky because the Earth wanders around like a top. 25,000 years is called precession. And so the pole star isn't the same as it was 2,000 years ago. And so there's that. But they got this all figured out and how long it's going to take to do that. And they wanted to know when it passed right through the band of the Milky Way. Because they could see the Milky Way, Hubble telescope. And to them, it was very important with their mythology to know when that was going to happen. The center of the Milky Way was going to be the solstice. And they calculated it. I don't know if you folks remember this. One of these big cycles to be December 21st of 2012. Now, I don't know about you, but on social media, there was building up. Like, what the heck's going to happen? You know, like, wow, the calendar's come to an end. Well, we'll find out. And again, this is the picture along the exposure of the Milky Way and the dark spot in front of it. So they had figured out when the solstice was going to happen. And so this long calendar they had, and this is how you write it out. And anyway, so question is, what happens at the end of that calendar year? I thought this was ran out. Well, what we found out was nothing really much happened. You know, it just, and according to their religion, you have another cycle. The whole universe dies and is reborn again in another cycle. So you don't have to panic. Yeah, everybody's going to go bye-bye, but we're all going to come back in another cycle. So, I mean, it's kind of cool. Now, if some of you want to get more into this, I certainly don't. There's a lot of stuff in this calendar. And you think when they did it, it's pretty cool. Okay, let's zip through the rest of the Mayans here in a second. Now, besides just astronomy, they were pretty big into STEM. Science, technology, engineering, and they built their pyramids and math, and they calculated the moon phases and crop harvest. They were pretty good. And the pyramids, all astronomically and mathematically hooked up. Exactly the ratios that they have predicted. Okay, is still time to go for a break? Okay, continue on. Observations. Now I'm going to talk about what do you see. So that's all about history and mythology. Although his first trial by the Catholic Inquisition was not until 1616, Galileo made some interesting discoveries. And so, of course, he invented the telescope, and he found out that Venus goes through phases like the moon. Well, wait a minute. What did we just tell you about the Catholic Church and Aristotle? Something's funky. The moon, they kind of assume, but not Venus. It's out there. And so he noticed this because he looked at it through his telescope and saw the phases of Venus. But he was chicken to publish it because he'd be in big doo-doo. But he finally did, 3 years later, in a book he did on sunspots. And the third thing, those of us that took Latin, he wrote to Kepler this secret Latin note, which, I don't know, the church people, maybe they read Latin, obviously, but, and Synthi Figaris, basically it says, he's writing to Kepler now and says, you know, Venus goes through phases like the moon. The love goddess, which is Venus, that's, you know, if you do the Latin, you go, oh, the love goddess is just like the moon, goes through phases. But nobody caught it, so he never got in trouble right down. So I thought that was kind of neat. So the same year he published the Starry Messenger about, we all know about Jupiter and yeah, seeing the moons of Jupiter, and that was a big deal. But I'm telling you, there's other stuff going on here. And these are the original drawings by Galileo of phases that he saw through his telescope over 5 months. Notice it's kind of big crescent, and as it gets more full, it gets smaller. Now, how do we know that's what he saw? Well, we can get our computer models up in software and compare the dates. So below is what our software shows us Venus really looked like then. It shows his data. He didn't just make this up. That's exactly how it was. Now, the other important thing is your model of the solar system with Earth in the center can't happen, and you can't get this. It's just, you just can't do it. And the drawing to show that this proves the heliocentric model and disproves the Earth-centered model. So we think about the Jupiter and the moons, yeah, that's kind of neat, and sunspots, but with his Venus, he absolutely 100% showed that this model that everybody had believed for all these years was absolutely wrong. So these are my 2 impressive images of Venus. So kind of a crescent on the left and one half on the right. That's the best I could do, folks. And this is neat because this is just a rare, it's called an occultation. You have Venus in that phase, crescent phase, and the crescent moon, and they happen to be right next to each other. And the reason I was excited about that is in any solar system, having an event like that I'm watching from the Earth, those 2 things happen in those phases of those things. It's just, it's once in a zillion. Okay, the next important discovery was that Venus has an atmosphere. Wow, 1761. And it occurred during the transit where Venus goes in front of the sun. And astronomers were very interested. So I will get through this and then we'll do our break. So it covers the sun's disk, and he watches it through his telescope from Petersburg. And he's so famous that 3 years later, after he publishes this, you're pretty good when you're an astronomer, and Catherine II, the Empress of Russia, comes to your pad and wants to talk to you. And so he was pretty famous polymath at that time. And these are some of his drawings of the edge of Venus near the sun. It comes right on, and I'll show you a little more pictures. And this is drawings by another, by Bergman, during the same transit, another scientist. And what's happening is where it's just touching the surface of the sun, or supposedly, it doesn't look quite exactly. See, there's a little smudge. There's going to be a little teardrop. You see that little smudge there? It isn't just like it's supposed to be. Well, he said that implies that it has an atmosphere. And there was another chance to look for that during an eclipse on Captain Cook expedition. So they were trying to figure out exactly, there's a lot of cool math you can do to figure out what an astronomical unit is, if you have this nailed perfectly. So they went to Pacific to try to find that, but it didn't come out quite as well as they thought. Well, that's nice. Oh, I don't know. And so this little teardrop effect, and there you can really see it, right? Now this is with our stuff lately, not what they had. And they finally actually named it for him. Now, why is this important and a big deal? Well, we'll take our break and we'll find out, leave you with a thought. There's an atmosphere on Venus now. Well, I mean, there could be oxygen, there could be planets, there could be people. So we'll see how that goes. And then, two, why couldn't you use this for other planets? Duh. So, some of you may have read, what is one of the things the Webb telescope is being used for now? Looking for atmospheres on exoplanets. So now we use the Webb telescope, we look at planets that are in other solar systems, not around here. And when a planet comes right next to that star, the Webb is powerful enough to analyze stuff, and not only can they can see if it has an atmosphere, but they can do other metrics, spectroscopy, to see what atmosphere might even be made of. Think of that, in another planetary system. So let's take a little break, coffee, and party break, or whatever you need, and then we'll see where this leads us. Now that we know there's an atmosphere on Venus, that's kind of exciting. There's people on there. Okay.
Let's gather back about 10:50. So just a few minutes. Move around. Are you good?
I think we're good, right?
You're good. All right.
Okay.
I'll hand it over to
Where
you.
is the Webb? No, telescope.
Well, I decided to put this picture up, which is obviously an artist's rendition of what appeared after the announcement that Venus has an atmosphere. So this is, they took a little artistic license in figuring what Venus must look like, right?
We all want to go.
That's right, book it
My
up.
next vacation.
But also, maybe higher life forms than just the vegetation. Those of you that know me know I'm not for science fiction and stuff. So I gotta digress here. On two movies about Venus. And of course, one of them was my favorite in 57, 20 million miles to Earth. And the probe is sent to Venus, talk about probe later, and it comes back with a small lizard-like creature. But it gets big like that. Now, not to give my age away, but I was about 10 years old when I saw that. And my cousin was 6 years older and took me to see it. And it scared the bejesus out of me. I had nightmares for a month. And I told Linda that we gotta see this movie again. It's still scary. Okay. Now, my mother let me go with him to see that. But notice the other famous movie of that time, in '58. Crew of 4 men wearing uniforms crash on Venus. But what's cool, it's a planet only of women in Zsa Zsa Gabor. Yes, they had. Well, did I see that movie? No. My mom and daddy didn't want me to go see that one. That was going to be too bad. Second, if she's monsters. So anyways, I don't know what that has to do with anything. So, spacecraft and probes. Over the next 2 centuries, no more significant information about Venus could be gleaned from Earth-based observations. You get big telescopes, bigger telescopes, nah, it is nothing for 100 years. So they finally figured out that if we want to learn more about Venus, we got to send something closer. Well, 46 space probes have been sent to Venus. And this is how many each decade. We started in the 60s, and less up to the 20s. And the first successful flyby was Mariner. It just went kind of by Venus, 60. And then the Russians, as you'll find out in a second, were really big on sending landers to Venus. And their Venera 7 was the first probe that actually returned data from the planet. And we'll find out why it was number 7. And then we had the Pioneer orbiters, and then more Vega spacecraft, and then Magellan. So let's talk about the Mariner. This is what it looked like. And as Americans needed first robotic encounter with another planet. We weren't doing too well in the space race at this time. I don't know if you remember. But the Russians were kind of kicking our rear ends. So we needed to have a breakthrough thing. So let's send a probe to Venus. And so we did. So 62, and it passed only 20,000 miles from Venus, which is really close. At a distance of 24 million miles from Earth. But think back then, it didn't even have a camera on it. We didn't have digital cameras that you could control from 24 million miles away and go click and tell it to do that. And think of how you would transmit data. But they did find out a couple things. They found that it didn't have a magnetic field or a radiation belt. Its atmosphere was mainly carbon dioxide. And it was pretty hot. So this is just a small amount of the copious printed paper data sent back. So imagine you're at JPL and all this data is coming back, and it's just stuff like this. Now, this is a real busy slide, and I'm just going to tell you a couple things about it, a couple highlights. And let's see, Sarah, where's the pointer on this thing? Oh, okay. So the highlight is 1, 2, 3, all these Russian probes down to here. They didn't work. They failed to send data back. They crashed. It's just they couldn't get any data back. Mess. Finally, Venera 7 in 70. And it is able to actually land on the surface of another planet. So think about that. Back then, we've landed on another planet, not on the moon, on another planet with a probe, not people. So that's pretty impressive. And then Venera 9, you go back there later, it is one, and it takes the first pictures, black and white, of another planet in the solar system. Pretty impressive. And then down to 13 and 81, color picture of another planet. So that is really good, and they transmitted more data. And then down here, the Russians, for 15, use radar to map the surface. You can't see under the clouds, but they use radar to see what's underneath it. So the Russians have a long history with trying to find out what's going on Venus. And this is the first black and white picture of the surface of another planet shortly before its transmission ended. Put that out for an hour or two. So we've seen some of the ones on Mars, but this is pretty impressive. And from their mapping, they came up with this map of Venus, what some of the surface would look like, with high and low places, and they named them. And that was in '83. And this is a picture of a 13 lander. This is the real first color of what the planet looks like. So those colors are what Venus' surface really looks like. Now, with all the data from these probes, orbiters, and landers, we now have a much clearer picture of what Venus is really like. And it's not pretty. So some of our early factoids that we already talked about are new. Yeah, distance from the sun, 65 million versus 93 for the Earth, and both the same size. But the surface temperature is quite different. 59 degrees here, average, not outside today, but up to 900 degrees on Venus. 900 degrees on the surface. Atmosphere, mainly nitrogen, and some oxygen here, but 96% carbon dioxide. Some more facts about Venus. Atmosphere thick with sulfuric acid clouds. Not water vapor, sulfuric acid. An intense greenhouse effect, which we're going to come back to a lot. The hottest planet. Think Mercury close to the sun. Oh, Mercury's getting toasted by the sun. No, Venus is much hotter due to the effect of the greenhouse. Takes longer to rotate than it does to orbit. So that's kind of screwy. It's got volcanic activity that it's had in the past. No liquid water on the, how are you going to have water 900 degrees sitting on the surface? Don't think so. Atmospheric pressure, 92 times that of the Earth. Wow, it's the same size. It's got this humongous pressure. So what color is Venus? Well, it's got all these reflective clouds, and so it kind of looks basically white to us. But NASA and other probes have shown that it's really kind of a deep reddish color, kind of like you'd expect to find on Mars. And it's what it looks like in regular light, imaged on the left, but on the right, that's what the radar can show imaging in false color. But you can see that it really does have terrestrial landmarks. This image uses ultraviolet wavelengths to show more contrast in the clouds. And one of my summer projects is I've got some, I think this is just tied, and it's the battery. Sarah?
Hey, JR, 2 seconds. Yeah.
Lost your volume.
Should we use the battery?
Yep, because there's no light even on here.
2 seconds.
Talk too long.
I'll talk very loudly while she's getting me a new battery here. So this, I expect sometime this summer, I've got the filters that are ultraviolet to see what it looks like through my telescope. I don't think I'll get this neat a picture, but anyways, gotta do something. Now, the atmosphere, ooh, good job. We now know a lot about the atmosphere. It's higher and thicker than the Earth's. Composed of carbon dioxide, different composition at different altitudes. Isn't that interesting? Wherever you are in there, it's different. Temperature varies and different. You'd expect it just to be colder when it goes up higher. Like, the Earth, you go up higher and it gets colder and colder. On Venus. And the weather system's very different from the Earth. And again, emphasize this, the pressure is 90 times that of the Earth. And for comparison, that's like equivalent to nearly a kilometer under the ocean. So the pressure just of the air, it's like it'd be going almost a kilometer under the ocean. Now, this is a pictogram of the atmosphere, outer space, hazy layers of sulfuric acid drops, thick clouds of sulfuric acid. That's what the clouds are, sulfuric acid. And fine sulfuric acid. But look what's down at the surface. Just carbon dioxide, no acid. So you're not going to get toasted by sulfuric acid if you stay close to the ground. It's all carbon dioxide. Not too good for breathing. Also, the Earth's atmosphere only goes about 10 kilometers high. The Venus goes 90 to 100 kilometers high. So its atmosphere is much, much, much higher. And again, it's mainly carbon dioxide, nitrogen, but it's got these other argon, sulfur, helium, other more minor. And traces of atomic oxygen have recently been found in the upper atmosphere. Upper atmosphere. Not oxygen O2, but atomic oxygen. This graph shows the temperature at various altitudes. And the scale is in Kelvin, which 0 is called absolute zero, but that's about 850 degrees at the surface. I think you get the idea. So what you see there is, here you're at the surface, 800 degrees, but the higher you go up, see the temperature changes very dramatically. And volcanoes, here's where you come into your acid levels. Now, entrapped heat from the sun is an extreme version of the greenhouse effect, which we're going to spend some time on. Some people say that it's as hot on the surface you can melt lead. Well, the greenhouse gas problem is obviously magnitudes of order worse than on the Earth. But it's the same chemical process. Everything that's going on, the chemistry is the same. It's just the quantity. And we'll see what that means later. These winds are unbelievable. 450 miles an hour. So you get up there and that's pretty impressive winds, isn't it? And the rotation of the winds, you can see on different planets. The Earth, what our weather looks like, what Mars looks like, what Titan, one of the moons of Saturn, looks like, and Venus. It's just got the super rotation. So the winds are just going, none of this other stuff. But this graph shows that the wind speed varies at the height. Okay? So at the ground, it's a slight breeze. So you go up here at 450 miles an hour. But at the ground, it's just the breeze. And again, the graph showing temperature, atmospheric pressure. So at the surface, it's really high. but the pressure is less and less as you go up. So here's pressure 90 times, but you go up here and you go, oh, 1 time. Oh, so right in this area, that's the same pressure we're having outside today here. But it's up there, right down here. Now, why does that happen? Happens for 2 reasons. The atmosphere is 9 times higher than the Earth's atmosphere. There's more weight, gas has weight, but it's carbon dioxide mainly, not nitrogen. Carbon dioxide is much heavier than nitrogen. So the combination of those two create that tremendous pressure. Acid rain on Venus? Yeah, but not at the surface. Talk about acid rain. On Venus, it snows metal and rains sulfuric acid. And hydrochloric acid and hydrofluoric acid too. But the acid rain never reaches the surface because of the Virga effect. And you go, what's the heck's the Virga effect? Well, you've all seen it. We've all seen it. You're driving out in the country or out west or someplace, and you see some clouds, and it looks like you can actually see the rain.
Yeah.
I think we've all experienced this. You see it, but it doesn't go all the way down to the ground, right?
Yeah.
Because it just stops. That's called Virga effect. It's also called a jellyfish cloud. But that's what's happening on Venus. Now, be aware that there'd be some different kinds of rain, what we call rain, on other worlds. And I like this slide because just to show all of us humans, it's a wild universe out there. So Earth, yeah, water. Venus, we just told you, sulfuric acid. Titan, methane. Neptune, diamonds. This other weird star brings glass. Another one, liquid iron. You go like, it's nuts out there. Unlike Earth, Venus lacks a magnetic field. And that has some significant effects on not having a magnetic core. And what happens is the solar winds come and you don't have this protective area around it, and it takes ions and just kind of blows them off into space. And we think, well, that's good. When Mars lost out of its magnetism, it changed its atmosphere. But Venus, we don't think had one, but we're not sure. And I like this because this is Venus up on the top in the Earth. See what the complex our magnetic field has? So all this radiation and stuff comes from the sun, gets deflected around and goes to the North Pole and the South Pole to cause the nice auroras, but it doesn't just toast us, and it doesn't just blow off all of our oxygen and our gases. Well, I didn't know this until I started doing this. Venus rotates the wrong way. Huh? So there's all the other planets, and they're all rotating one way, and then there's Venus, it's rotating the other way. And there's different theories of, and probably one of the ones is it eventually got hit by another asteroid or other planet and changed it, but that's kind of interesting. Some other theories about friction from the inside, but we're not concerned with that. So, composition and surface. Most of our knowledge of the solid planet comes from our probes and orbiters, not landers, because the landers haven't done too well, have they? But, looking back, how would you design a probe that's going to go through that pressure, that acid temperature? Of course, the Russians, the first 7, didn't make it. They didn't have a clue. They'd have to put all these acid-proof things, and they did pressures and stuff until they started to figure some of this stuff out. Although there were a number of spacecraft that imaged the planet, the Magellan orbiter required the most data. And the Magellan 89, NASA, got a NASA representative in the audience here someplace. And it used radar to detail a map. Did over 800 orbits and got 98% of the surface. And it really contributed to our understanding of the atmospheres in geology. Unlike the other planets, Mercury, Earth, Mars, and Venus is composed of a hard, or of a core, a surrounding mantle, and a crust. So it's called the terrestrial planets. They're pretty much the same. And from the mapping, this pretty much covers the whole planet. It's kind of not really exciting, but what are the things that we see on there? This is called Mont Mons, a massive Venusian shield volcano, the planet's second highest mountain. It's 5 miles high. It was named after the Egyptian goddess of truth and justice, Mont. Now, I thought this was interesting. So you're discovering all these things and you gotta name them. So let's call them this, that, or whatever. Well, the International Astronomical League is charged with naming different planets and space places. And they said, we're gonna use women.
Yay.
So the theme of women, historical and mythologic. So far, there are over 2,000 named features. There are only 3 big land areas, and one of them is named for Aphrodite, Terra. You know who she is? Ishtar, Terra. Babylonian, Lada Terra, Slavic goddess of love. So see how this theme for Venus, love, comes back in the naming. There's one exception. The only exception to female naming is Maxwell Mountains, large mountain. And it's the tallest mountain on Venus. And it was named for the famous James Clerk Maxwell. So some of you are familiar to who he was, but for those of you who are not, he was a Scotch physicist and mathematician who was responsible basically for the classical theory of electromagnetic radiation. This was the first theory that kind of described electricity, magnetism as light, these kind of different manifestations of the same phenomenon. So he published his equations and all this in 1865, about this time of Civil War. But it eventually led to the technology that allowed the mapping of the planet through thick clouds by spacecraft. So his technology allows us to map this. So we're making an exception. We're letting this one male dude get some notoriety, which I thought was probably justified. Now, it's still going on. And this one girl I saw online, I think college was someplace, Kavya Baraja, decided she'd make a website. And this is her website. So you can go on and check out all the names of all these places, and she's got them all categorized. But this is a summary. What percent are writers, what percent are scientists, performers, advocates, mobility, educators, and heroines. So I thought that was kind of neat. Now, anybody in here want to get named? So if I or somebody discovers another thing on name, we can nominate you. Put you down. Jan, would you like to get nominated? Except there's a problem. You must have been dead for at least 3 years. So you want to renege your thing? Okay. I thought that's kind of cool. You got to be dead for 3 years before they'll name you. Now, this is an artist's rendering of the surface of Venus. I don't know about you, but it looks a little hellish to me. And again, this is the only real picture from the surface. The 13 lander in 1882. Now, what are about all these volcanoes? There's a lot of volcanoes on there, and it says 350 years ago. Now, what we find out is there's these large volcanoes, there's pancake volcanoes, but there's not a lot of craters like the moon, because craters haven't been hitting the solar system for billions of years, or at least a half a billion years. And so we find out the surface looks a lot like this. And this is a large, what we call a shield volcano. And this was not obtained from the surface of the planet. This wasn't from their Voyager or one of the Russian probes, but it's 3D. And you go, well, how does that work? Well, this is a 3D image I did last year of the crater Copernicus. And you go, well, wait a minute, that looks like that was taken from the moon. Well, it's data that I sent in to an astrophysicist in Italy, and he got all the data from the lunar orbiter and put it all together and was able to make a 3D image like that. So you can make a 3D image of another planet that you've never been to just with radar flyby. And there's these pancake domes. And what we find is that it's going to look like a pancake. And basically, the whole planet has had lava pavement at different times. So that's why you don't see a bunch of craters. History and evolution. Now we're winding down and getting to more of the interesting, well, significant stuff. Now, a much clearer picture of the history of our solar system. Now, it first formed 4.6 billion years ago. And the point here that I emphasize is that the other planets are very different billions of years ago from what we see today. But now we understand what they were like in the past. What can we expect in the future? So when everything was formed and our solar system formed about 4.6 billion years ago, all this dust coalesced to form the sun and the planets. And where did that dust come from? Supernova explosions. So we are all of you in here, all of our matter is basically from supernova stars blowing up, and some of it getting formed into the Earth and then into us. Now, these are the composition, average temperatures and atmospheres of the terrestrial planets at present. You don't see in the atmosphere much, very thin around Mars. You can see a little bit there. The Earth, only 0.03% carbon dioxide. Venus, 96%. And of course, we already talked about this, the thickness of the atmosphere and the temperatures of the atmosphere. But this slide I find very interesting. Compare our present atmosphere to that early in our history. I think it's pretty impressive how similar the first three bar graphs are. So this is Venus and Mars and the original Earth. I don't know about you, but I don't see much difference in those three. So our Earth, just like those, well, in the early days, and look where it is now, totally different. So what are the lessons we can learn from the study of Venus? Evolution. And you don't have to be a rocket scientist or a scientist to figure out that the greenhouse gas effect could be a contributor. So first, Venus went from that to that. Then Mars went from that to that. Well, duh, what do you think is going to happen next? The Earth could go from that to that. So the question is, what will the Earth look like in the future? And are we paying enough attention to the man-made greenhouse gases? Because what happens is there's a point that it accelerates and you get more greenhouse gases and it gets hotter. And that's just carbon dioxide, it's methane, and then it gets hotter. But then it gets hotter, and then it gets hotter. And then pretty soon you boil the oceans. Oh, now how's things gonna go for you? And then it makes it hot, there's nothing to absorb, and there's no ice, and you just see how it just keeps going on and on. Now, I'm not personally worried about it in the next 20 years, so, but I think this is very interesting. So, future probes and exploration. So, looking for life on Venus. You know, life on Venus, acid, temperature. What do you think the chances are if you had to bet there's any life on Venus? 5%, 2%? Probably not too much. Wrong. There is a spot, but look where it is. It's in the clouds, where the pressure is the same as it is on Earth. The temperature is down reasonable, and there's other chemicals around floating in there. So if there's life on Venus, or has been, it's in the clouds. Okay, you skeptical people, what kind of life you're gonna have? Well, how many of you know about hydrothermal vents on Earth? Talk about an hospitable environment for life to arise. Hundreds and hundreds of degrees, no oxygen, no sunlight, no photosynthesis, lots of sulfur compounds and hydrogen sulfide. And so instead of photosynthesis, chemosynthesis goes on, and there are lots of organisms that are growing down there around these vents. So even on Earth, we have a role model example for that. So these vents may hold the secret to the origin of life on Earth. Also, we talk about coming from asteroids. Most recently, they found a 3.42 billion year old fossil microbe in an ancient hydrothermal vent. Wait a minute. Basically, that's what the Earth was like back then, 3 billion years ago. No oxygen, no stuff in the atmosphere. So we're finding a fossil that's that old, and that's making us all rethink life, planetary stuff. Now, so what was it like 3.8 billion years ago? So pretend you were an alien, and you were cruising around in your spaceship, and you come to our solar system, and you're looking for a potential place to colonize, because you've trashed your planet, and you gotta look for someplace else. And you cruised our solar system, about 3.8 million years ago. Which planet are you thinking about colonizing? So, again, I love this astronomy because it gives you a wider perspective of time. So if some alien came to the moon and they checked the Earth out, they go, oh, this is not a good spot. So what will we look like down in the future? Who knows? Okay, life on Venus. Phosphine gas found on clouds on Venus. Whoa, what about that? Well, it's spotted in the planet clouds again in 2023. So 3 years ago they found it, and they found it again. So scientists have to reproduce stuff. Well, gee, it's generated by microorganisms living in a very low oxygen environment. It's not made in any other way on our planet. So it's not proof, but it's saying maybe there's something going on up in the clouds of Venus. Okay, so how to answer these questions? Is there life on Venus in the clouds or not? Well, the answer is send more probes. So let's just wind up about some of the probes that we're going to be sending, and then we'll ask for questions. This is a European Space Agency probe sent to go in the 30s. Veritas, NASA project. Global gas and stable isotope tracking. First private mission to Venus is coming up. Rocket Lab, MIT's Venus Life Finder. And they would like to send a probe down into the atmosphere and really see what's going on. But as we found out, it's pretty hot there, so you need to have a heat shield. It's going to 4,500 degrees coming through that atmosphere. So how do you prepare for that? So I want to throw this in because I think it's important. Cutbacks in U.S. research funding are having many academics in our country get recruited to France. Why? If you're a scientist and you're working on a project for 4 or 5 years, whether it's microbiology, astronomy, and all of a sudden your place is funding's getting pulled. Use the language, what the hell are you going to do? You're screwed. You're going to wait till the top of the sun and say, oh, let's reinstate those. You've lost the time, the energy. So other countries like France are saying, brain drain, this is an opportunity. You come over here, we're going to guarantee you can work on your project for up to 5 years and have funding. So I see this as a real problem that we're in right now in July of this last year. However, if we can get our politics and respect for scientific research back on track, the Da Vinci probe certainly looks like the most promising to send back a plethora of data. So, it's an acronym for Deep Atmospheric Venus Investigational of Noble Gases, Chemistry, and Imaging. And that is supposed to be a video, but we'll see if it really happens or not. And the answer is, it doesn't. So that was just to show this probe's going to go there, and it's going to orbit for a while, and then it's going down. It's really impressive. So I guess we don't have our internet hooked up. Okay, so in concluding, I said I know Peg Watson's going to ask me a question. Well, where can I see Venus tonight? You know, if I go out tonight, or where is it? Morningstar? Well, right now, let's look at Venus events. You see, as January 6th, it went too close to the sun, so you're not going to see it. Well, it's popping out now on the east in the evening sky. So you're going to start seeing Venus higher and higher as the evening star. And it'll reach its highest point on August 15th. And then it'll start going down lower and lower. Brightest on September 18th. October goes back in the sun. And then January of next year, you're going to see it as a morning, quote, star. And how far can it get? So some people say, what's that planet? So Linda and I will go out and I go, she said, what's that really bright thing up there? And I go, it's Venus. I go, no. That's why we're going to this fact. Venus can only be 45 degrees to 48 degrees high. It's an inferior planet. And I'll show you a picture why in a second. So if it's higher than that, it can't be Venus. Oh, some other, it's Sirius, it's another star, it's an airplane, or maybe it's Jupiter. But, so you can, that's nice to know. So Venus is always doing that. And so that's why. It's an inferior planet, so it can only get so high in the sky. That's what, okay, so, conclusion, I hope that the next time you see Venus as a morning or an evening star, you recall something from this presentation. And I'm going to just do one more slide and then say thank you for your attention. And the slide is, So the last slide was the Des Moines Astronomical Society. Slide 172 and 172. Let's see if it's, yeah, there it is. Okay, great. So anyways, I just wanted to, we had an astronomy club meeting, so I'm a member of the Des Moines Astronomical Society. We have an observatory that shows you a sky view of it from Ashton. So I hang out there different times in the summer, not in the middle of winter. And we have presentations and lectures, and we have tons of telescopes, and we have domes, and we have telescopes, and those people can look at different stuff. So it's a fun thing. If you're interested, you can take a picture of this with your phone after, or I'm just going to leave it up, or DesMoinesAstronomical.com. So I said I put a plug for those of you who want to learn more about Venus or just astronomy in general. So thank you all.
We are a little past our time, like 5 minutes. It's okay. So maybe if there's one question.
And I'll hang out after.
Yeah, and then you have
People have other questions.
questions.
Hang around.
Well, I was wondering if it's so hot, why don't the probes melt? They
Can you
can't
repeat
get
the
close
question?
enough for
Yeah, the
information.
question is, why don't those probes melt? And the answer, most of them did. And so now when they engineer them, they gotta make them like stuff that would go in your oven. And not, because your oven gets pretty hot too. And so now that they know at least the temperature they're dealing with, yeah, so good question. I wouldn't want to redevelop them.
Thank you, Dr. Paulson, for this presentation. It was awesome today. Thank you.
And it's fish next month.
Next month is Fish from Dr. Paulson, but I was also going to say next Wednesday is a presentation from the Executive Director of the Grinnell Historical Museum, Bethany Hewlett. She will be here, so please plan on returning next week. It's just for an hour, and have a great rest of your day. Thank you for being here.
Thank you.